All right, if you're anywhere near the world of big data, you've absolutely heard the name Apache Spark. It's, one of those foundational tools for chewing through massive data sets. But what actually makes it so special? Well, let's pull back the curtain and see what makes this thing the go-to engine for big data. So to really get why Spark was such a big deal, you have to know what came before it. The old king of a hill was Hadoop MapReduce, and it was revolutionary for its time, but man, was it slow. And that's because it had to write data back to a physical disk after every single little operation. Spark completely changed the game with its secret weapon, in-memory computation. This made it up to 100 times faster. But speed is only half the story. It's also a unified engine, which means you can do all sorts of data jobs: batch, SQL, streaming, machine learning, all in one place. So here's our game plan for this explainer. First, we'll talk about the big data problem that made Spark necessary. Then we'll peek under the hood at its secret engine. After that, we'll get into the building blocks for its data, explore its super versatile toolkit, and finally, we'll wrap up with how to really put Spark to work. Okay, so let's start with the problem itself. Data just started exploding, right? And the old systems, the ones that relied on writing to disk all the time, they just couldn't keep up. It was like trying to empty the ocean with a bucket. The world desperately needed something that wasn't just faster, but also way more flexible to handle all these different kinds of data processing jobs. And that need brings us right to Spark's secret engine. So how does it pull it off? How is it so fast and so versatile? Well, it all boils down to a pretty simple but really powerful architecture that has two main players. First up, you've got the driver program. The best way to think of this is as the manager, or maybe the brain of the whole operation. It's the thing that runs your main code, and its whole job is to figure out what needs to be done, break it into smaller pieces, and then coordinate all the work across a whole cluster of computers. Now, if the driver is the manager, then the executors are the team members. These are the worker processes that are spread out across all the different machines in the cluster. They get their assignments, their tasks from the driver, they do the actual number crunching on their little piece of the data, and then they send the results right back. And here's how that whole manager and team relationship works. It's kind of like a four-step dance. The driver kicks things off, it assigns tasks out to all the executors. Then the executors get to work crunching their piece of the data all at the same time in parallel. And once they're done, the results flow right back to the driver. It's this elegant, distributed system that is the real secret to Spark's incredible power and scale. Okay, so now we get the engine. But what about the fuel? The data itself? Spark has actually evolved quite a bit in how it thinks about and represents data. And understanding that evolution is really the key to unlocking its true power. In the very beginning, everything in Spark was built on this one thing, the RDD, which stands for Resilient Distributed Dataset. And it's a pretty brilliant idea. It's basically data that's spread out across the whole cluster, and it's built to be super tough. The resilient part means if one machine fails, no big deal. Spark can just rebuild its piece of the data. And the immutable part means you can't change it, which makes running things in parallel way, way safer. Now, RDDs are really powerful, but they have one little blind spot. They don't know anything about the structure of the data inside them. So for things like data analysis, where you've got nice, neat columns and rows, Spark needed something better. And that something better is the DataFrame. Honestly, if you've ever used a spreadsheet, a database table, or even pandas in Python, you already get this concept. It's just data, but it's organized into named columns. Except this spreadsheet is spread across a massive cluster of computers. So what's the big deal here? Well, if you compare them side by side, it's pretty stark. RDDs are raw. You kind of have to do a lot of the optimization work yourself. Data frames, on the other hand, have a schema. They know the column names, they know the data types, and that knowledge lets Spark do massive automatic optimizations for you right under the hood. You can think of this Catalyst Optimizer as this super smart planner that works behind the scenes. You give it a simple request, like filter this data and then group it, and it figures out the absolute fastest, most efficient way to get that done across the whole cluster. It gives you these incredible performance boosts, basically for free. So we have a crazy fast engine and a really smart way to handle data. This foundation is what allows Spark to be more than just a single tool. It's more like a complete toolkit, a Swiss Army knife for pretty much any data task you can dream up. First up in the toolkit is Spark SQL, and this is a huge deal. It means that any data analyst out there who already knows SQL, which is basically the universal language of data, can suddenly command the power of a giant computing cluster. You don't have to write a bunch of complicated code. It totally democratized big data processing. Next, there's Spark Streaming, which is all about handling data that never stops. It has this really clever approach where it takes a live stream, chops it up into these tiny, continuous micro batches, and then just runs them through the normal Spark engine. This is the magic behind things like real-time fraud detection systems and those live analytics dashboards you see. And of course, we have to talk about machine learning. MLlib is Spark's scalable ML library. It comes packed with a whole suite of common algorithms, but the really crucial part is that it lets you build these things called pipelines that can automate your entire machine learning workflow, from cleaning the data all the way to training your model on massive data sets. And finally, for more specialized problems, there's graphics. This is Spark's library for analyzing data that looks like a graph. Think social networks or transportation routes. It comes with optimized algorithms like the famous PageRank to help you find patterns in all that connected data. Okay, we know what Spark is, we know what it can do, but knowing how to use it well, that's what separates a job that takes hours from one that takes minutes. So let's wrap up with some absolutely essential best practices for getting the best performance. Let's run through some real pro tips here, because this stuff is fundamental. First, do whatever you can to minimize data shuffling. That's when Spark has to move data between machines across the network. It's almost always your biggest bottleneck. Next, caching data you use over and over again, total no-brainer for a massive speedup. And simple things like using efficient file formats and filtering out data you don't need as early as possible, they can make a night and day difference. Mastering these is how you unlock Spark's true speed. And why does all this matter? Well, it all comes back to this number. The whole reason Spark took over the big data world was its incredible speed. And applying these best practices, that's how you actually get to that full potential. And this chart just spells it out perfectly, right? You start with a basic job, and maybe it's kind of slow. But just by adding caching to a data frame you're using a lot, boom, it gets faster. Then you switch your data to a columnar format like Parquet, and the performance jumps again, even more dramatically. Each one of these practices just builds on the last. So what's the big takeaway when you boil it all down? Spark is a powerful, incredibly fast, and unified engine that was built from the ground up to solve the challenges of big data. And through its Python API, PySpark, it makes all that incredible power accessible to one of the biggest communities of data people in the world. Spark was the perfect solution for the problems of its time. But as this sheer volume and speed of data just keeps exploding, it leaves us with one final thing to think about. What new challenges are out there, and what will the next generation of data tools need to conquer?